The year is 1940. In Germany, engineers at the Messerschmitt factory near Augsburg proudly watched their new Bf 109 fighter planes roll out, one every few days. Sometimes two if they push hard enough. They smile with pride. The Luftwaffe rules the skies of Europe. Poland has fallen. France is gone. Britain struggles under constant air attacks. German aircraft seem unbeatable. Advanced engines, powerful guns, modern designs. Then, someone mentions America. Laughter fills the factory. America, they joke. That country still makes old biplanes. Their air force is tiny. They can't even build a proper tank. One engineer laughs, saying, by the time Americans learn how to build good planes, the war will be over. But across the Atlantic, something big is already happening. In Michigan, inside a huge empty car factory, a man named Charles Sorensen from Ford Motor Company is making a wild promise. One bomber every hour. Not one a week. Not one a day. Every single hour. The military officers can't believe it. The B-24 Liberator bomber is huge and complicated. More than 1 million parts, hundreds of thousands of rivets, miles of wiring. Building one usually takes months. Sorensen doesn't argue. He simply says, watch. What happens next will shock Germany more than any secret weapon or battle plan. Because Sorensen and thousands of American workers are about to prove a simple truth. Wars aren't just won by soldiers. They're won by factories. This is the story of how America's car makers turned into plane makers. How Detroit, Seattle, and Long Beach workers built not just planes, but victory itself. By turning the power of mass production into the most powerful weapon of all, numbers. They didn't just fight the war. They built the victory. To really understand what scared Germany during World War II, you first need to understand what they could never imagine. In 1940, airplane factories in Europe still used old-fashioned methods. Skilled workers built each plane almost by hand, like making a custom piece of furniture. Every aircraft stayed in one place while teams of workers walked around it, attaching parts, drilling rivets, and connecting wires. It took weeks or even months to finish one plane. The quality was great, but the speed was painfully slow. That year, Germany built about 10,000 planes. Britain made around 15,000, pushing their workers and factories to the limit. Japan built about 4,800. These were strong numbers, proof of years of hard work, skilled labor, and industrial strength. And then there was America. In 1940, the United States built only 6,000 military planes. Germany saw that number and smiled with confidence. America, they thought, was hopelessly behind. But what Germany didn't know was that number was about to explode faster than anyone thought possible. Because in Dearborn, Michigan, a man named Henry Ford had been perfecting something for 30 years that Germany had never really used in airplane production: the moving assembly line. Now, Ford didn't invent it. Others had tried before, but he made it perfect. Back in 1913, his factory in Highland Park changed manufacturing forever. Before the assembly line, it took over 12 hours to build one Model T car. After the line was introduced, just 93 minutes. The secret wasn't just dividing the work. It was changing where the work happened. Instead of workers walking around the car moved to them. Each person did one small job over and over until they became incredibly fast at it. Parts came exactly when needed. No wasted steps, no wasted time. Using this system, Ford built 15 million Model T cars. Now, in 1941, his team looked at the massive B-24 bomber blueprints and asked the question that shocked everyone. Why can't we build planes the same way we build cars? Military officers laughed. They explained that airplanes aren't cars, they're much more complicated. Planes need parts that fit with extreme precision. They have hydraulic systems, electrical systems, oxygen lines, and weapons. They must survive freezing air and enemy fire 25,000 feet in the sky. Charles Sorensen, Ford's top production expert, listened quietly. Then he started designing a new kind of factory, one the world had never seen before. It was called Willow Run. Construction began in April 1941. The main building stretched 3,200 feet long, more than half a mile, and 1,200 feet wide. It became the largest room under one roof on Earth. Inside, a single assembly line ran almost a full mile. Workers called it the Run. Some doubters called it Willow Run because they didn't believe it would ever work. The idea was bold, even crazy. Raw materials would enter at one end, and piece by piece, the plane would take shape. Separate assembly lines would build the fuselage, wings, engines, and tail sections. Then they would all come together, and out of the far end of the factory would roll a fully built bomber. Every 63 minutes. At first, it was a disaster. Parts didn't fit. Measurements were off. Workers who used to build cars struggled with the delicate details of airplanes. Rivets cracked, pipes leaked, and electrical systems failed. German spies heard about it and reported that the Americans had failed. They were relieved. Mass production doesn't work for aircraft, they said. Planes need skill and patience. The Americans are wasting their time. But the Americans didn't stop. Engineers redesigned tools and machines. They broke down each job into smaller, simpler steps. They hired tens of thousands of women who proved amazingly skilled at precise work. They built training programs so that an ordinary person, even a grocery store clerk, could become a skilled riveter in just 2 weeks. And slowly, it started to work. By late 1942, Willow Run produced 1 B-24 per day. By mid-1943, 1 every 4 hours. By 1944, 1 every 63 minutes, exactly as Sorensen had promised. And Willow Run was only the beginning. In Seattle, Boeing built the huge B-17 Flying Fortress in multiple factories at once, coordinating with thousands of smaller suppliers. In California, Douglas Aircraft turned into a massive aircraft producer. In Connecticut, Pratt & Whitney used the same mass production system to make aircraft engines faster than ever. Then came the numbers, the ones that made German intelligence officers' blood run cold. In 1941, America made 19,000 planes. In 1942, 47,000. In 1943, 85,000. In 1944, 96,000 military aircraft. That's more than Germany and Japan combined, doubled. German intelligence officers refused to believe it. They said the numbers must be fake, Allied propaganda. No country could build planes that fast. Then they looked up and saw wave after wave of bombers flying over Germany. The 8th Air Force would send out hundreds of B-17s. Even if Germany shot down 20 of them, a huge loss. 3 days later, the Americans came back with 40 more than before. Every plane lost was already replaced, and more had been built. Germany's armaments minister, Albert Speer, later wrote that this was the moment he realized Germany could not win. It wasn't about one battle or one mistake. It was about numbers. In 1944, Germany built 40,000 planes at full capacity and still couldn't keep up. They lost pilots faster than they could train new ones. They ran out of fuel, materials, and time. Their factories were bombed again and again. America built 96,000 planes without even slowing down. The simple idea of bringing the work to the worker, the moving assembly line, had become the most powerful weapon of the war. Because these factories didn't just make planes faster. They made them cheaper, smarter, and in numbers so great, the enemy could no longer keep up. It wasn't just an industrial miracle. It was the production of victory itself. In 1942, building a German FW-190 fighter plane costs around 120,000 Reichsmarks. An American P-47 Thunderbolt, on the other hand, costs about $85,000, which equals roughly 340,000 Reichsmarks if you compare currencies. German economists feel pleased when they see that number. To them, American planes are expensive and wasteful. They believe America's mass production system builds planes quickly, but at the cost of efficiency and economy. What they don't realize is that American costs are falling fast. At the Republic Aviation Factory in Farmingdale, New York, engineers follow Henry Ford's assembly line ideas like a religion. They study every single detail of how the P-47 is built, every tool, every process, every movement. And they constantly ask one question: how can we make this plane faster, cheaper, and better? Soon, they discover something incredible. The more planes they build, the cheaper each one becomes. This idea shocks people who are used to the old way of manufacturing. In traditional factories, one skilled worker takes a set number of hours to finish one plane, so every plane costs about the same. But on an assembly line, the math changes. The first P-47 off the line takes about 10,000 man-hours to build. The 100th plane takes 6,000 hours. The 1,000th, only 3,500 hours. And by 1944, Republic Aviation can build a P-47 in under 1,800 hours. The cost per plane drops too, from $85,000 to $83,000, then to $78,000, and finally $73,000. It's the same plane, same quality, same performance, but built with half the labor. Germany simply can't match this. Their factories are smaller and less standardized. They build maybe 100 planes a month, while America builds 1,000. When production is that large, even tiny improvements save huge amounts of time and money. By the end of the war, America builds 15,683 P-47 Thunderbolts. Germany builds 20,051 FW-190s. Impressive at first glance, until you realize those are split into a dozen different versions. Each version needs different tools, different parts, and even different training for pilots and mechanics. That's where American standardization becomes a secret weapon. Take the B-24 Liberator bomber as an example. By 1944, 5 factories are building B-24s: Ford's Willow Run, Consolidated in San Diego, Douglas in Tulsa, North American in Dallas, and Consolidated in Fort Worth. Every single one uses the same blueprints, same tools, and same parts. That means a wing built in Michigan fits perfectly on a body built in Texas. This terrifies German logistics officers. When a Luftwaffe squadron loses an FW-190A-4, they can't just replace it with an FW-190A-8. The later version has different weapons, engines, and systems. Mechanics need retraining, parts inventories must change, and repair manuals no longer match. But when an American unit loses a P-51D Mustang, they get another P-51D Mustang. Exactly the same down to the rivet. The pilots already know how it flies. The mechanics already know how to fix it. The parts already fit. And this standardization goes beyond airplanes. The .50 caliber machine gun, for example, is used on B-17 bombers, P-51 fighters, and even tanks and jeeps, all in the same way. A bomber pilot trained on B-24s can switch to B-17s in a matter of days, because the controls and systems are similar. German pilots switching from Bf-109s to FW-190s need weeks of new training. These small differences add up to something massive. Lower production costs mean more planes for the same money. Standardization means faster repairs and less downtime. Interchangeable parts means simpler logistics. And easier training means more pilots ready for combat. By 1944, Germany builds 1 fighter for every 2.5 American fighters. But even that number doesn't show the full picture. When you look at operational availability, how many planes are actually ready to fly at any time? The gap grows even wider. German units often operate at 40 to 60% readiness. They lack spare parts, and their mechanics are exhausted. Damaged planes can sit for weeks waiting for repairs. American units often reach 80% or higher. If a plane is damaged, it's fixed within days or replaced entirely. Parts arrive in endless streams from well-organized supply chains. Mechanics use the same manuals, the same tools, and the same designs for every aircraft. A German squadron with 30 planes on paper might have 18 actually flying. An American fighter group with 75 planes can send 60 into the sky. The math becomes crushing and unstoppable. But the real revolution isn't only about building planes cheaper. It's about building so efficiently that America can afford to make entirely new kinds of planes, bigger, faster, and stronger, while still outproducing the enemy by miles. In 1936, a new American bomber takes to the sky, the Boeing B-17 Flying Fortress. German officers read its specs and laugh. For engines, 10 crew members. Fully loaded, it can weigh 65,000 pounds. It's built to fly at 25,000 feet, carry 5,000 pounds of bombs, and reach targets 2,000 miles away. To them, it seems crazy. They have a word for this: gigantomania. A love of making things huge and expensive for no good reason. Why build a heavy 4-engine bomber when smaller 2-engine bombers do the job? Heavy bombers cost much more. They need more crew training. They drink huge amounts of fuel. The Germans point out that their Heinkel, He-111, and Dornier Do-17 medium bombers work very well in Spain, Poland, and France. They are fast, they turn well, and they don't waste fuel. For the price of one heavy bomber, the Luftwaffe can build 3 mediums. That sounds smart. But the Americans have a different problem and a different idea. The United States sits behind 2 big oceans, so any war will likely be fought far away. Planes must travel very long distances. Medium bombers simply can't reach far enough. Heavy bombers can. More than that, many American planners remember the horror of World War I trenches and ask, can air power stop wars without sending millions of men into slaughter? What if you could destroy an enemy's ability to fight by bombing their factories, oil plants, and cities that keep their war machine running? This idea is controversial. Some generals call it wishful thinking. But American strategy picks it: build heavy bombers, and build a lot of them. At first, the cost looks impossible. In 1942, a B-17 costs about $238,000 to build. By 1944, that price falls to $204,000 as factories get faster and smarter. The B-24 Liberator costs around $215,000 in 1942 and drops to $180,000 by 1944. Those numbers still sound high until you compare them with German heavy bomber efforts. Germany's only real heavy bomber, the Heinkel He-177, costs over 600,000 Reichsmarks, about $240,000, and, worse, it has big design problems. Its paired engines often catch fire. Only around 1,000 are ever built, and most are rarely flyable. Meanwhile, America builds 12,731 B-17s and 18,482 B-24s. The scale is almost unbelievable. By 1944, the 8th Air Force in England can send more than 1,000 heavy bombers on a single raid. Each bomber can carry up to 8,000 pounds of bombs and is defended by as many as 13.50 caliber machine guns. When 1,000 B-17s and B-24s fly over Germany together, they bring with them 8 million pounds of explosives and 13,000 machine guns, all in a single mission. German fighter pilots look up at those long lines of bombers and feel despair. They call the 4-engine planes Wehrmachts, 4 motors. Attacking them is deadly. Letting them pass is worse. The constant sight of bomber streams, day after day, wears down German morale. Luftwaffe pilot Johannes Steinhoff later writes that seeing those endless formations made him feel as if the war was already lost. But it isn't only the number of bombers that matters. It's what the American factories let commanders do with them. German planners treat each bomber as precious and rare, so they plan raids carefully and only send planes when conditions look perfect. The Americans treat many bombers more like powerful weapons that can be risked. If a raid loses 5% of the force, that is painful but acceptable. 10% losses hurt, but the factories can replace the planes. The production lines build replacements faster than German defenses can destroy them. On October 14, 1943, the 8th Air Force strikes the ball-bearing factories at Schweinfurt and loses 60 bombers out of 291, a terrible 20.6% loss. Most air forces would need months to recover. The Americans come back 11 weeks later, with more bombers than before. German industry cannot match that kind of recovery. When the Luftwaffe loses hundreds of fighters in a month, those losses stack up. Factories can't make new planes fast enough. Pilot training cannot replace the men who are lost. Fuel and parts run short. Factories themselves get bombed. American losses often disappear into the huge output of its industrial base. By late 1944, the Luftwaffe faces a problem it cannot fix. They can see the bombers coming, they can send fighters to intercept, and sometimes they even win the fight. But the next day there are more bombers, and then more the day after. The factories never stop. Heavy bombers are only one part of the plan. They need protection on long missions, fighters that can travel with them to the target and back. And American factories are building those too. The combination of huge, long-range bombers and steady fighter production, all powered by mass production, changes the war. It turns industrial strength into military strength, and that strength becomes almost impossible for Germany to match. It's 1943, and American bomber commanders are facing a serious problem. Our fighters can't fly far enough, they say. Their B-17s and B-24s fly deep into Germany during daylight raids, relying on the idea that tight formations and heavy defensive guns can protect them. But that idea turns into a nightmare. The moment American escort fighters reach the end of their fuel range and turn back, German fighters strike hard. The bombers are left alone and torn apart in brutal attacks. Losses rise to levels that can't be sustained. America desperately needs long-range escort fighters, planes that can fly to Germany and back while still fighting effectively. But experts say that's impossible. Fighters need to be light, fast, and agile. To fly farther, you need to carry more fuel, which makes the plane heavier and slower. You can have a good fighter or a long-range fighter, but not both, or so everyone believes. Then a group of engineers in Inglewood, California, working at North American Aviation, decide to challenge that idea. Led by Edgar Schmud, they design a new aircraft, the P-51 Mustang. At first, it's not great. The early Mustangs use Allison engines, which perform well at low altitudes, but struggle high up, where bombers operate. Then someone has a bold idea. What if they install a British Rolls-Royce Merlin engine, the same one used in the famous Spitfire? That single change transforms the Mustang completely. Now it's fast, powerful, and smooth at high altitude. The P-51 can fight toe-to-toe with the best German planes. But it still can't fly far enough, until another breakthrough comes along. Engineers decide to hang extra fuel tanks under the wings, called drop tanks. When the fuel runs out, the pilot can simply drop them off before entering combat. With two 108-gallon drop tanks, the P-51D Mustang can now fly 1,650 miles, enough to reach Berlin and back from England. This changes everything. In late 1943, the first long-range Mustangs arrive in Europe. German pilots who used to wait safely deep inside Germany suddenly find American fighters flying right beside the bombers and coming after them. One German pilot, Heinz Nock, writes in his diary, "For the first time, American escort fighters have reached the Hanover area. We thought we were safe here. We were wrong." But the Mustang's role goes beyond just escorting bombers. American commanders give a new order: don't just protect the bombers, attack the enemy. Hunt the German fighters. Destroy them in the air. Wipe them out on the ground before they can even take off. The P-51's long range makes that possible. Mustangs escort bombers, fight in the skies, and strafe enemy airfields on their way home. One plane, many missions. And American factories produce them in huge numbers. At North American's Inglewood plant, workers build 25 Mustangs every day, one every 36 minutes. Each Mustang costs about $51,000 in 1944, a bargain for such an advanced aircraft. Germany's Bf-109G, by comparison, costs about 180,000 Reichsmarks, or around $72,000, and still can't match the Mustang's range, speed, or firepower. In total, America builds 15,586 P-51 Mustangs during the war. But the Mustang isn't fighting alone. Another American fighter, the P-47 Thunderbolt, becomes a legend of its own. At first, pilots laugh at it. It's huge, weighing over 17,000 pounds, heavier than some bombers. German pilots nickname it Jug, short for Juggernaut, or Milk Jug. They think it's too big and too slow. Then they meet it in battle and stop laughing. The P-47 carries 8.50 caliber machine guns, fires with incredible power, and its strong radial engine can take heavy damage and keep flying. In dives, it's almost unstoppable, able to break away from any German fighter. And just like the Mustang, The Thunderbolt rolls out of American factories in massive numbers. 15,683 P-47s are built before the. By 1944, America produces over 38,000 fighters, while Germany struggles to make 25,000, most of which are desperately used to defend their own cities. The math tells the story. A German fighter unit might lose 12 planes in a single day. Replacements arrive slowly. The new pilots? Many have only 100 hours of flying experience, some as few as 30. They face American pilots with 400 or more hours of training. Flying planes that are replaced faster than the Germans can destroy them. The result is inevitable. Even Germany's top ace, Gunther Rall, who shot down 275 aircraft, later admitted, "We could shoot down 20 American fighters, and 30 would replace them. We couldn't win a mathematical war." Because America didn't just build planes. They built an entire machine of war, from pilots to fuel, from spare parts to replacement aircraft. It wasn't just skill or courage that won the skies. It was production, organization, and endless determination. Every time a B-17 Flying Fortress takes off for a bombing mission, it burns around 4,000 gallons of aviation fuel. Now imagine 1,000 bombers flying together. That's 4 million gallons of fuel for one single raid. And that's not all. Add the fuel for 500 escort fighters, plus oil, hydraulic fluid, oxygen tanks, ammunition, spare engines, propellers, and tires. Then remember, these massive raids happen every single day. The scale is almost unbelievable. When German planners look at these numbers, they think it's impossible. No country, they believe, can keep up with this kind of consumption. Surely the Americans will run out of fuel, parts, and pilots. But they're wrong. Because what the Germans don't realize is that America isn't just building planes. It's building an entire system to keep those planes flying. By 1944, the United States produces 1.5 billion barrels of oil. Germany, by comparison, manages only 50 million. That's a 30-to-1 advantage in fuel production. American fuel doesn't just come by ship or truck. It literally flows through pipelines under the ocean. The operation is called Pluto, Pipeline Under the Ocean. After D-Day, these pipes pump fuel from England to France, and by the end of the war, they're carrying millions of gallons every day. While German planes sit idle, waiting for fuel, American bombers are flying through skies the Germans can no longer defend. And fuel is only the beginning. Let's talk about spare parts. When an American P-51 Mustang needs a new engine, mechanics simply request one. Within a few days, sometimes even hours, a fresh engine arrives, fully packed, tested, and ready to install. The old one is shipped back for repair or reuse. In Germany, things are completely different. Spare parts are scarce. Rail lines are bombed. Factories can't keep up. When a German Bf-109 needs an engine, it might sit broken on the airfield for weeks, waiting for replacement parts that never come. The difference is logistics. American factories don't just build 15,000 Mustangs. They also build over 30,000 spare engines and millions of parts. They build the trucks to move them, the ships to carry them overseas, and the depots to store them safely. They build a complete support network. Germany's system runs on scarcity. Everything is rationed, recycled, or improvised. Mechanics have to cannibalize parts from wrecked planes just to keep a few aircraft flying. America's system runs on abundance. Need spark plugs? There's a crate of 1,000. Need tires? There's a warehouse full. Need a whole replacement plane? It's already on the next ship. Because of this abundance, American ground crews fix planes faster, replace entire engines instead of repairing them, and keep a far higher percentage of aircraft ready for combat every day. And the same level of organization extends to pilot training. By 1944, American schools are training over 65,000 pilots per year. They have thousands of aircraft used only for training. New pilots typically fly 150 to 400 hours before joining combat units. Germany trains only about 15,000 pilots a year, often using planes desperately needed at the front. Many of these new pilots log just 50 to 100 hours of training. The result? A young German pilot with barely any experience might face an American veteran with 400-plus flight hours in a superior plane. The outcome is obvious, but the American advantage doesn't stop there. Factories are organized for speed and scale. New aircraft roll off the line, get test flown, and are ready for shipment within days. They're packed efficiently onto ships, sent across the Atlantic, and assembled quickly at forward bases. From factory floor to combat unit, it takes only a few weeks. In Germany, planes often sit for months waiting for fuel, parts, or transport. So when an American fighter is destroyed in combat on Monday, a replacement often arrives by Thursday. The squadron barely notices the loss. In Germany, if a fighter is destroyed, it can take 6 weeks or more to replace. Pilots are left flying shorthanded. Squadrons slowly shrink. Even Albert Speer, Germany's armaments minister, later admitted he was shocked when he visited the front. American forces had endless lines of fuel trucks, mountains of spare parts, and rows of ready aircraft. German units, meanwhile, were counting bullets and rationing gasoline. But perhaps the biggest American advantage wasn't mechanical, it was human. American pilots flew a set number of missions and then rotated home to train new pilots, passing on what they'd learned in combat. This created a continuous cycle of experience, veterans teaching rookies who became veterans themselves. Germany couldn't do that. Every skilled pilot was needed at the front. They flew until they were killed, captured, or too wounded to continue. By 1944, most of Germany's veteran airmen, the ones who conquered Poland, France, and nearly won the Battle of Britain, were gone. The new pilots were young, undertrained, and facing impossible odds. Meanwhile, American squadrons were full of both veterans and learners, constantly improving their tactics and teamwork. The gap between the two air forces wasn't just about machines. It was about knowledge and organization. German ace Adolf Galland later summed it up perfectly. In 1944, we were sending boys against men. Boys with 100 hours against Americans with 400. Boys in worn-out planes against men in the best fighters ever built. It was murder. This logistics miracle, the fuel, the factories, the training, the organization, made sure that American air power didn't just stay strong. It grew stronger every month. While the Luftwaffe faded away, the American war machine only gained momentum. And yet, one final advantage was still waiting to reveal itself. The one thing that would make American air power truly unstoppable. In early 1944, German radar operators noticed something strange and worrying. During raids, American bombers start dropping clouds of thin aluminum strips. On the radar screens, those strips show up as many fake targets. The Germans call this trick window. The Americans call it chaff. It's simple, clever, and it works. German radar-guided anti-aircraft guns suddenly cannot tell real planes from false blips. Night fighters struggle to pick the real bombers out of a sea of ghosts. The idea came from the British, but American factories make chaff in huge amounts. Every bomber carries bundles of these strips. Hundreds of bombers drop millions of strips. German radar systems are partly blinded almost overnight. This chaff is just one example of how American innovation quietly supports air power. While German engineers often chase very complex technologies, jets, rockets, and new wing shapes, American inventors focus on practical improvements that soldiers and crews can use now, and that factories can make in large numbers. Take gun sights. Early in the war, pilots used simple reflector sights and hoped for the best. American engineers build the K-14 computing gun sight, a gyroscopic sight that helps calculate lead automatically. The pilot frames the target, and the sight shows where to aim to hit a moving plane. It's not science fiction. It's a simple tool that works very well. Factories install it on thousands of fighters, and American gunners suddenly become more accurate. German pilots notice the difference in combat right away. Or take self-sealing fuel tanks. Before this, a single bullet in a fuel tank often meant the plane would catch fire and crash. American factories developed tanks lined with rubber compounds that swell when fuel leaks, plugging small holes. These self-sealing tanks become standard on American aircraft, not an optional upgrade. When a German pilot hits an American plane's fuel tank, the plane often keeps flying. When an American pilot hits a German tank, the German plane often burns. Over time, this simple protection saves crews and planes again and again. These small, practical changes add up. American bombers get self-sealing tanks, armor to protect crews, backup control systems, better oxygen gear, standardized emergency tools, and first aid kits. Each addition makes the planes heavier and a bit more expensive. But when you build tens of thousands of aircraft, adding a 20-pound armor plate is easy. American mass production soaks up the cost. For Germany, which builds far fewer planes and struggles for materials, each new feature forces painful trade-offs. Weapons follow the same logic. The American .50 caliber machine gun is powerful, reliable, and standardized. The same ammo works in aircraft guns, vehicle guns, and ground mounts. German weapons use many calibers: 7.92 millimeters, 13 millimeters, 15 millimeters, 20 millimeters, 30 millimeters, which means many types of ammunition, different spare parts, and more complicated supply lines. American logisticians love standard weapons because they simplify supply and maintenance. Even more important is organization. The Americans build systems for better coordination between air and ground forces. Forward air controllers guide fighter bombers to targets. Radios improve. IFF, identification friend or foe, systems reduce friendly fire mistakes. These tools are not flashy, but they multiply combat power. AP-47, guided by a forward air controller, can knock out enemy tanks and then return to escort duties, all thanks to the system around the airplane. By 1944, American tactical air power works like a finely tuned machine. Close air support arrives fast when ground troops call for it. Fighter bombers coordinate with tanks and infantry. Everything functions together. German ground troops, by contrast, often lack air support because the Luftwaffe is tied up defending against strategic bombing. When a German soldier looks up, it's usually an American plane. When an American soldier looks up, it's always friendly air cover. That constant overhead presence crushes German morale. But innovation is not only about new gear. It's about learning and adapting fast. When German fighters attack bombers head-on to avoid defensive fire, American engineers add nose guns to B-17s. When Germans change tactics, American pilots and engineers find counters. Ideas from the front spread quickly. A maintenance sergeant invents a faster way to load ammunition, and within weeks other squadrons use it. A pilot creates a new formation. It's tested, improved, and shared. The American system rewards feedback from the field and implements useful changes fast. German military culture, by contrast, often resists bottom-up change. Commands come from the top, and every modification must pass through many layers of approval. That slows adaptation. The Americans encourage small-scale experiments and rapid improvements, which makes the whole force smarter, faster, and stronger. By the end of the war, the combined effect of American production, practical technology, logistics, and fast learning equals a crushing advantage. Innovation and manufacturing work together to create air power that is not only huge in numbers, but smarter, tougher, and more adaptable. Yet, even with all these planes and advances, there is still one final element that makes American air power unstoppable. One last advantage Germany did not expect. February 1945. The city of Dresden is burning. The firestorm covers 15 square miles of the city's center. The flames reach temperatures of more than 1,500 degrees Fahrenheit, hot enough to melt steel. Winds roar like hurricanes, pulling people and buildings into the fire. In just one night, between 25,000 and 35,000 people die. This isn't careful bombing. This isn't hitting just military targets. It's total destruction, the planned burning of Germany's cities, one after another. And the reason it's possible is because of American factories. German commanders understand tactics, airplanes, and weapons. But what shocks them most is something different. The unbreakable determination of American air power to keep bombing, week after week, month after month, no matter how hard it gets. It's not just power, it's willpower. From 1942 to 1945, the Allied bombing campaign against Germany becomes the largest and longest operation in history. Allied bombers fly over 1.4 million missions and drop 2.7 million tons of bombs. The cost is enormous. The U.S. 8th Air Force alone loses 26,000 killed and 20,000 wounded. Any other air force might collapse under such losses. The Americans keep going and even grow stronger. This is what the Germans never fully understand about American industry. The same mass production mindset that builds cars and airplanes also drives the bombing campaign. If a target is identified, send the bombers. If the weather is bad, try again tomorrow. If losses are high, build more planes, train more crews, and return next week. It's a machine-like rhythm, steady and unstoppable. By 1944, this campaign becomes terrifyingly efficient. Raids of 1,000 bombers or more are now routine. The U.S. 8th Air Force and Britain's RAF Bomber Command hit different cities at the same time, stretching German defenses thin. One by one, the cities fall into flames: Hamburg, Berlin, Cologne, Munich, Nuremberg, Essen, Frankfurt. Every week, another city burns. Back in America, factory workers read newspaper headlines about these raids. They see photos of burning cities, and then they go right back to building more planes, more bombs, more engines. It becomes a cycle of production and destruction. German morale begins to crumble. Not just soldiers, but ordinary civilians. Goebbels' propaganda machine works overtime, promising new secret wonder weapons that will save Germany. But when air raid sirens scream, people rush to shelters, and what they hear above isn't wonder weapons. They hear the deep drone of hundreds of American bombers every single day. This, too, is part of the strategy. American planners know that destroying factories is important, but destroying German willpower is even more effective. When a worker in Essen sees his city bombed 3 times in 1 week, he can't sleep. He can't work well. He worries for his family. Multiply that feeling by millions of people in hundreds of cities, and the whole war machine starts breaking down. By mid-1944, German production begins to fall, not just because factories are gone, but because the system itself is collapsing. Trains can't move supplies. Roads are destroyed. Workers are dead, exhausted, or terrified. Raw materials can't reach plants. Finished weapons can't reach the front lines. The bombing campaign works not through perfect aim, but through constant, crushing pressure. And only the American industrial machine can sustain it. Look at the numbers. In 1944 alone, American factories produce over 2 million tons of bombs. That's 4 billion pounds of explosives. Every single pound has to be made, filled, packed, shipped, and loaded. Factories run 24 hours a day. Women take over production lines, working faster than ever before. The same assembly line methods used for cars are now building weapons. Rosie the Riveter becomes the symbol of this massive workforce. Millions of American women who build planes, bombs, and engines. Nearly 20 million Americans work in war production. Germany, with half the population, mobilizes fewer, about 14 million, and still produces much less. The math alone tells the story. Germany cannot keep up. But it's not only about numbers. It's about the American mindset. When faced with a powerful enemy, the U.S. approach is simple. Don't look for clever tricks. Use overwhelming force. If you can't outsmart the enemy, outbuild them. If you can't win a dogfight, build 10 more fighters. If you can't precisely hit a factory, destroy the whole industrial area. If you can't break their will to fight, burn their cities until they surrender. Many people, even at the time, are horrified by this logic. But it works. By early 1945, Germany's war economy collapses. Oil production drops to just 20% of what it once was. Railroads are shattered. Factories that still stand have no power, no fuel, and no workers. The Luftwaffe has planes, but no gasoline to fly them. Army units have guns, but no bullets to fire. German General Heinz Guderian later admits, "The American air campaign did not defeat us in one big blow. It defeated us through 1,000 small cuts, each one weakening us until we could no longer resist." But there's also a darker truth. The bombers don't just target weapons factories. They hit cities, homes, and workers' housing. The line between civilian and military blurs. Even Allied soldiers and pilots feel uneasy, but the bombings continue. For American leaders, the calculation is cold but clear. If bombing shortens the war and saves Allied lives, then keep bombing. Some citizens question it, but most support it. When newspapers report successful raids, people cheer. When factories call for more workers, they show up. The home front and the battlefront become one. By April 1945, no major German city is left untouched. The Luftwaffe is gone, the economy is ruined, and American factories are still rolling out new planes. The war is almost over, and yet thousands of bombers remain unused, still fresh from the assembly line. Even after victory, the sheer scale of American production shocks the world. If the U.S. could build 96,000 aircraft in 1 year while fighting across 2 oceans, what could it do in peace? For Germany, that question doesn't matter anymore. They've already learned the final and most painful lesson of the war. The most powerful weapon in history wasn't the bomber itself. It was the factory that built it. May 8, 1945, victory in Europe. The war is finally over. Inside the massive Willow Run factory, the endless sound of machinery comes to a stop for the first time in 3 years. This is the place where 8,685 B-24 Liberator bombers began their journey to war. The air feels strange, silent. One worker remembers, "We didn't know what to do. We've been building one plane every hour for so long." The silence felt wrong. When you add up everything America built during the war, the numbers don't even seem real. From December 1941 to August 1945, American factories produced 300,317 military aircraft, 88,410 tanks, 257,390 artillery pieces, 105,055 mortars, 2.4 million trucks, 2.6 million machine guns, 41 billion rounds of ammunition. And they did all this while still producing goods for civilians, feeding allies through Lend-Lease, and raising the largest army in U.S. history. Meanwhile, in the ruins of Germany, captured officers tried to explain how they had so completely underestimated American strength. Their answers differ, but the themes are the same. They never understood how American industry really worked. European factories were built around craftsmanship, skilled workers making things by hand, scaled up just enough for war. American factories were machines that built machines, vast, automated, standardized, and built for speed. It wasn't a small difference. It was a completely different world. They also didn't understand American flexibility. German industry was famous for precision engineering, but it was slow to change. Everything had to go through layers of approval. American industry experimented constantly. If something didn't work, they tried again, fast, bold, and at massive scale. And they couldn't grasp America's access to materials. Germany fought with shortages everywhere: fuel, metals, rubber, even food. Every resource was rationed, reused, and stretched thin. America, on the other hand, believed in abundance. If they needed more steel, they built more steel mills. If they needed more fuel, they drilled more wells. If they needed more planes, they built more factories to make them. But the biggest thing Germany misunderstood was American determination. In 1940, Germany looked across the ocean and saw a sleepy giant, an industrial country that seemed divided, isolated, and unprepared. They saw a small army, smaller than Romania's. They saw outdated aircraft and an air force barely beginning to modernize. What they didn't see was the potential waiting to be unleashed. The same factories that built Fords could build bombers. The same workers who made refrigerators and radios could make guns and engines. The same system that mass-produced prosperity could mass-produce war. Even Hitler himself mocked this idea. In 1942, he reportedly said, "The Americans cannot build aircraft. They are a nation of refrigerators and radios." By 1945, those refrigerator factories had built more planes than the rest of the world combined. That mistake cost Germany everything. But the story doesn't end with Germany's defeat. The factory revolution that powered American victory reshaped the entire post-war world. The Soviet Union studied America's production system closely. Stalin's new factories copied American assembly lines, turning industrial competition into the foundation of the Cold War. Britain, though it invented many aviation technologies, realized it could never match American production. After the war, it focused on specialized aircraft rather than mass production. Japan, under American occupation, learned deeply from the system. Companies like Toyota studied Ford's methods, improved them, and created what became known as lean manufacturing, a process that would eventually surpass its American inspiration. The world had learned a clear lesson. In modern war, industrial power wins. Not courage alone, not tactics alone, not even advanced technology alone, but the capacity to build, replace, and sustain endlessly. Victory belonged to the side that could produce faster than the enemy could destroy. The side that could replace every loss in days, not months. The side that could fight forever if needed. That idea shaped global military planning for decades. But behind this giant industrial machine were ordinary Americans, the human side often forgotten in the statistics. They weren't soldiers. They didn't carry rifles or fly missions. They were factory workers, millions of them. Many of them women who had never worked outside the home before. One of them, Inez Sauer, who worked at Boeing's Seattle plant, later said, "We built the planes that won the war. Not soldiers, us. Regular people working 10-hour shifts, 6 days a week. We didn't think about it like that at the time. We just knew our brothers and sons and husbands needed those planes." At its peak, the aviation industry alone employed over 300,000 people. If you add the workers making engines, weapons, instruments, and parts, the total climbs past 1 million. Every worker was a single gear in a massive machine that answered the attack on Pearl Harbor with overwhelming strength. The Willow Run plant alone employed 42,000 workers, running 24 hours a day in 3 shifts. It had its own fire department, police station, hospital, and cafeterias. It was like a small city built for one purpose, to build bombers. Most workers never saw a finished plane take off. They installed one part, a rivet, a wire, a panel, again and again. But together, their hands built an air force. German workers worked just as hard. German engineers were just as skilled. But America's system, its assembly lines, standard parts, and rapid organization, made each worker several times more productive. One American aviation worker could produce as much as 3 or 4 German workers. Not because Americans worked harder, but because their system worked smarter. That was Henry Ford's legacy to modern warfare. The same assembly line that once put America on wheels now put the world under wings. In 1940, Nazi leaders laughed at the idea that America's factories could matter in a world war. By 1945, American bombers darkened their skies. The final lesson was clear and absolute. The most powerful weapon of the war wasn't the airplane, the tank, or the bomb. It was the factory that built them. Today, Willow Run still exists, but only a part of it. Most of the huge factory has been torn down. Some areas are now covered by grass and trees, while a few sections have been turned into other buildings. Still, part of it remains, protected as a piece of history. Visitors can walk the same paths where B-24 bombers once rolled off the line, one after another, every single hour. Now it's quiet, completely quiet. Inside a small museum on one end of the old factory, one single B-24 bomber has been restored and kept in flying condition. Tourists come to take photos, read the signs, and imagine what this place must have looked like during the war years. But when you stand in the middle of that empty space, where thousands of workers once stood, you feel something that pictures and words can't describe. You feel the scale, the courage, and the unbelievable idea that people once believed they could build warplanes the same way they built cars. And the truth is, they did. Factories like Willow Run all across America helped win World War II. Of course, it wasn't just the factories. Soldiers, pilots, and commanders also played their parts with bravery and sacrifice. But without those factories, none of it would have been possible. Germany had brave soldiers. They had amazing pilots. They had advanced technology and clever tactics. But they didn't have a Willow Run. They didn't have the American factory spirit, the belief that any problem could be solved through teamwork, machines, and mass production. When Charles Sorensen stood in that empty warehouse in 1941 and promised, "We'll build one bomber every hour," people thought he was out of his mind. But he wasn't crazy. He was American. The war proved something powerful. Modern wars are not just fought with courage. They are fought with industry. It's not enough to have good weapons. You must have lots of good weapons. It's not enough to have good soldiers. You must be able to replace every loss and still grow stronger. And for that, you need factories. When German General Wilhelm Keitel signed Germany's surrender in 1945, he reportedly said, "They simply had too many aircraft. We could not compete." That one sentence revealed the real truth. Germany didn't just lose on the battlefield, they lost in the factories. They tried to fight a mass production war using old-style, craftsman thinking. They focused on quality when the war was about quantity. The American factory system didn't just build airplanes faster, it changed what war itself meant. It proved that organized, industrial teamwork could defeat even the best pilots or most advanced machines. One great German ace pilot might shoot down hundreds of planes, but one American factory could build thousands more in the same time. It was simple math, and Germany didn't believe it until it was far too late. In 1940, German engineers laughed at America's ability to build airplanes. By 1945, no one was laughing. Because the Americans didn't just catch up, they buried Germany under a storm of aluminum, steel, and rivets. They proved that the assembly line, that simple idea from a car factory in Michigan, had become the most powerful weapon of the 20th century. Not because it made the best planes, but because it made more planes than the enemy could ever destroy. Faster, cheaper, stronger. The factory system that once built 10,000 planes faster than anyone thought possible became the shortcut to victory. And it all began with one man, standing alone in an empty warehouse, staring at blueprints for a bomber, and asking one simple question. Why can't we build these like cars? The answer was clear. You can. And America did. Between 1941 and 1945, American factories built more airplanes than Germany, Japan, Britain, and the Soviet Union combined. The Willow Run factory alone produced 8,685 B-24 Liberators. That's one bomber every 63 minutes, just as they promised.